Good morning. Welcome back. Now we are discussing a concept of determining rigidity modulus as well as moment of inertia by two different methods. One is static method and the other is dynamic method. First of all, we are discussing the determination of rigidity modulus by static method, and this is the experimental setup used to determine the rigidity modulus by static method. And here we have a rod AB, you can see here rod AB, and this rod AB is fixed at the end A rigidly, whereas the other end B is fitted to the axle or the axis of a wheel, and this wheel is mounted on ball bearings. A tape is wound over the groove of the wheel, and its end of the tape carries a weight hanger. The rod AB will be twisted if we add weights to the weight hanger. The twist at the two different points along the length of the rod can be measured by making use of circular scales S1 and S2 and the pointers P1 and P2. The scales are marked in degrees as shown in figure. These are the two scales S1 and S2, which consists of two pointers P1 and P2, which are attached to the rod. When the rod gets twisted, we can measure the angles theta1, theta2, which are in degrees. The points are fixed at convenient distances from the fixed end of the rod, that is end E. The dead weight, that is weight hanger alone. For the weight hanger alone, the pointers are adjusted to read 0 on the scales S1 and S2. Now, on adding weights in the steps of 0.25 kg, and for each weight added, the readings are noted on the two scales S1 and S2, which gives theta1 and theta2 respectively. And these readings are noted both while loading as well as unloading, both while adding load to the weight hanger as well as when removing the load from the weight hanger. In both the cases, we measure or we note the readings theta1 and theta2. And the experiment is repeated by reversing the windings of the tape on the wheel so that the rod gets twisted in the opposite direction. From these observations, the twist produced for a load m kg corresponding to length L of the rod is determined. Radius of the rod is small a. Radius of the wheel is capital R, and both are measured. When a load of m kg is suspended from the free end of the tape, then the twisting couple is given by the expression mgr. If theta degrees is the angle of twist, then theta in degrees will be equal to theta into pi by 180, and that will be in radian. The restoring couple is given by the expression pi eta a power 4 by theta 4 eta a power 4 into theta by 2L, and this will be in degrees. And if we convert it into radians, we get pi eta a power 4 theta by 2L into pi by 180 radian, where eta is called the rigidity modulus of the material of the rod. And for the system to be in equilibrium, test the twisting couple balances the restoring couple. That is, therefore mgr is equal to pi eta a power 4 theta by 2l into pi by 180. Simplifying this or rearranging the terms, we get the expression for rigidity modulus eta equals 360 mg RL by pi square a power 4 theta, or eta is equal to 360 gr by pi square a power 4 into ml by theta. And this rigidity modulus can be calculated using this expression by knowing radius of the wheel, radius of the rod AB, load added, that is m, length of the rod, and what is known as the deflection. Now coming to the second method of finding the rigidity modulus, that is the dynamic method. So here we make use of a torsional pendulum, and this torsional pendulum can be made in order to determine the rigidity modulus of the material of the wire, this wire. The experimental wire is fixed vertically to a rigid support with the help of chuck nut. This is the chuck nut at end A. This is the end A. Whereas the lower end of the wire is connected to or is fitted to a circular metallic disc with the help of chuck nut B at its center. Two masses, let us say m each, are kept on the disc along the diameter at distances d1 from the wire on both sides as shown in figure. The disc is slightly rotated through an angle theta, and then the disc is released. Now the disc executes torsional oscillations about the wire as axis. The period of oscillation T1 is determined by noting the time for a definite number of oscillations, say 10 oscillations or 20 oscillations. Then the period of oscillation T1 is given by the expression 2 pi into root I1 by C, where C is the couple per unit twist, or squaring on both sides, T1 square is equal to 4 pi square into I1 by C, where I1 is the moment of inertia of the whole system, that is disc as well as the masses m kept on either side of the wire about the axis of rotation, and C is the couple per unit twist of the wire. If I0 is the moment of inertia of the disc alone, that is in the absence of masses m about the axis of rotation, and I is the moment of inertia of each mass m about the parallel axis through its center of gravity, then by parallel axis theorem we have I1 is equal to I0 plus 2I plus 2m d1 square. Therefore T1 square becomes 4 pi square by C into I0 plus 2I plus 2m d1 square. Now the experiment is repeated by changing the distance of each mass from the axis of rotation, by changing d1 to a new position or to a new distance d2, either by decreasing or by increasing, and the corresponding period t2 is determined using this relation, that is t2 square is equal to 4 pi square by C into I0 plus 2I1 2I plus 2m d2 square. Therefore, taking the difference of these two, we get t2 square minus t1 square is equal to 4 pi square by C into 2m into d2 square minus d1 square, where C is pi eta a power 4 by 2l, where A is radius of the wire, suspended wire, and L is length of the suspended wire. Therefore, t2 square minus t1 square will be equal to 4 pi square into 2l by pi eta a power 4 into 2m into d2 square minus d1 square. That will be equal to, therefore, finally 16 pi ml by eta a power 4 into d2 square minus d1 square. Therefore, finally, rigidity modulus eta equals 16 pi ml into d2 square minus d1 square divided by a power 4 into t2 square minus t1 square. And radius of the wire A can be measured with the help of screw gauge, and hence we can finally determine the rigidity modulus of the wire by dynamic method. Thank you.